An actuary determines that the annual number of tornadoes in counties P and Q are jointly distributed as follows. Calculate the conditional variance of the annual number of tornadoes in county Q, given that there are no tornadoes in county P. So if we let FQP be the joint PMF, it doesn't matter whether you go with PQ or QP. Here, QP is more convenient because we have to find the conditional variance of Q given P equals 0. So it's more convenient to write it this way. So we need to get the variance, conditional variance, we get the corresponding conditional PMF. So we need the PMF of Q given 0, because that's the variance we need. We need the conditional variance of Q given P equal to 0. So we need the PMF of Q given P equals 0. So that's the normal formula. It's F of Q and 0, so which means Q is Q and P is 0, divided by P0, so FP0, where FP0 is obtained by basically adding up the row corresponding to P equal to 0. So the columns correspond to Q, the rows correspond to P, so this is the row P equal to 0. So P equal to 0 will be this plus this plus this plus this, adding up the P equals 0 row entries. So we get 0.25. So therefore, we'll be dividing each of FQ0 by 0.25 to obtain F of Q given 0. And FQ0 corresponding to 0, 1, 2, 3 for the Q when P is fixed at 0 is here. Q would be 0, 1, 2, 3. So it's 0.12, then 0.06, 0.05, 0.02, 12, 0.06, 0.05, 0.02. And then you divide each of these by the 0.25 to get these. And now we can do the variance on calculator. And let's do it. So clear the data first. So data again, enter. So data, go to 2, enter to clear. So now it's been cleared. So the first column was 0, 1, 2, 3, if you remember. 0, 1, 2, 3. So these were the values, and these are the probabilities. These are the values, and these are the conditional probabilities. So 0, 1, 2, 3 for the first column. 0, 1, 2, 3. 0, 1, 2, 3. And then second column, let me tell you a trick about the second column or the probability column. So actually we have a nice trick there. So you see all these values are something over 25. Now this column is just a weight column, and it doesn't matter whether you do 12 over 25, 6 over 25, 5 over 25, 2 over 25, or you do some common multiple of all these. So one convenient common multiple which we can use is 25. So what I'm saying is, if you multiply all this column by the same number, it will not affect the variance or the standard deviation, because these are just the weights. So here it's very convenient to multiply all these by 25 so that I get 12, 6, 5, and 2. So 12, 6, 5, and 2, 12, 6, Oh, what's going on? So let's give. So this one needs to be 12, 6, 5, and 2. And now we are ready to do our second stats. One variable, data is in L1, frequency is in L2, and enter. So you need the sigma x. So the standard deviation is 0.9928. 0.9928. And you need the variance, so you square it and you get 0.99. So remember, since we needed the conditional variance Q given P equal to 0, maybe it's better to write here is Q given 0. And then you needed the F of Q given 0 and not this one. This was just an intermediate thing. So when we square it, we get 0.99, and that is choice D.